In this example, we want to prove rigorously that these two functions, f of x equals 2x plus 4 and g of x equals 1/2 x minus 2, are inverses of each other. Now, because it says confirm or prove, that means in every case. It's not enough just to do it for one particular number. We have to do it for all cases. So to do that, we're going to use composition, and we have to show that f of g of x and g of f of x are both equal to simply x, that they both take us back to x. So we do this one piece at a time. So let's say we do f of g of x first. Okay, now that means we're going to take g of x and substitute the expression for g of x into f. Now g of x is 1/2 x minus 2. We're going to put that into f. Okay, so f of x is 2x plus 4. So f of g of x is going to be 2 times, now instead of x, we're going to use g of x. So we're going to take this expression and put it in there. So it's going to be 2 times 1/2 x minus 2 plus 4. So if we multiply that out, we're going to get 2 times 1/2 is just 1x, 2 by minus 2 is minus 4, and then plus the 4 in the end is equal to x. So f of g of x is equal to x. Now that is one part of what we wanted to do. We had to show that f of g of x is equal to x. Now we're going to do the second part, which is to show that g of f of x is equal to x. So let's try that now. So part B is to get g of f of x. Okay, so we're going to start with f of x. Start with the inside one. So f of x is equal to 2x plus 4. And what we're going to do is we're going to take this expression and put it into g. Okay, so now g of x is 1/2 x minus 2. And what we're going to do is we're going to take f of x and put it into g. Okay, so we're going to take this expression for f of x and put it into g. Okay, so that's going to give you g of x is equal to 1/2 of 2x plus 4. Let's get that bracket just to make it look better. Minus 2. And if we distribute the 1/2, this is going to be g of f of x, I beg your pardon. A couple of mistakes creeping on here, sorry. G of f of x. So this is going to give us g of f of x. 1/2 of 2x is just x. 1/2 of 4 is 2 minus 2. So g of f of x. X plus 2 minus 2 is just x. So now if you look back at the two boxes, we have f of g of x is equal to x and g of f of x equals x. We had to prove it both ways. To do it once is not enough, you have to prove it both ways. Okay, so we had to show what this looks like graphically. And I've already drawn the graph, so I'm just going to copy it in here now, hopefully. If we can paste. And this is the graph, and it's very small. Let's see if we can spread this out a little bit and make it look a little bit better for you. And I'll resize that a little bit later on, but for now in the video, this is how it's going to be. The function in red here is f of x. The function in the function in blue is g of x. And the line that splits them up the middle is the line y equals x. And you can see that it splits them symmetrically. In other words, one line is the reflection of the other in this line y equals x. And as long as the green line is always y equals x, okay, this has to be the line y equals x, okay, then if two functions are the inverse of each other, you'll always get this pattern. You'll always have the two lines split exactly down the middle by the line y equals x. Okay? So hopefully that makes sense. Thanks for watching.